this is Chemnoel. We're on channel QT, and here's another installment of Just a Safety Minute.
In this episode, let's talk about gas density. When do gases sink? When do they rise? We know that air has a molar mass of 29 grams per mole, if you like units. Gases with a molar mass bigger than 29 will sink. Those with a smaller molar mass than 29 will rise. Where does that 29 come from? Well, it's simply a weighted average calculated from air. All gases eventually will diffuse completely, so we can use very simple math to come up with a weighted average molar mass for air. So let's say we have 78% nitrogen, which has a molar mass of 14 times 2 is 28. And we have 21% oxygen, which has a molar mass of 16, times 2 for O2 is 32. And 1% everything else, which is mostly argon, which has a molar mass of about 40. We'll divide that by 100% to take care of all the decimals and units. And that comes up with a final value of 28.96, which we simply round to 29. And that's where 29 comes from. If you get fancy and add other gases, you'll just tweak the number a little bit finer. But that looks good to me, so let's go outside and see some demos, maybe burn some stuff.
We're talking about gas density, so we have some hydrogen and a bubble solution, so we're making some bubbles. Hydrogen is H2, so that's about 15 times lighter than air. So we're trying to make a nice big bubble here if we can, and we'll see if it goes up or down relative to air. Oh, look, it goes up, 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 way up in the sky. Now we have some propane, again our bubble solution, and we think these should be heavier than air. Propane is C3H8, so that's 12 times 3 is 36, plus 8 is 44, so about 1.5 times as heavy as air. Let's see if this falls down as we would predict from the molar mass. Try and get a nice big bubble. Oh, there we go, look at that. So we made some bubbles. We can't make bubbles with gases and not add some flame. To have some fun and convince you I really am dealing with hydrogen and propane. They're both flammable gases. So we have a flame device. I have lots more PPE on now. I have some Nomex and gloves, a face shield, and we can see what happens when we add some flame to our bubbles. Okay, so let's give propane a try. Hydrogen was a little anticlimactic. We'll have our bubbles again. We'll see if we can make a nice bubble here. And again, this is heavier than air, so it wants to sink. And let's see if this burns also. Oh, look at that. Okay, as a final demo, we have some bubbles left in the dish. Let's get rid of those. Oh yeah, there we go.
Okay, bonus round. For those who want to think about how the world works, we came up with 28.96 for our molar mass for air earlier. Have you ever wondered, what about humid air? Again, we can do a weighted average. Let's say we have 95% dry air, and let's add 5% water to it, which has a molar mass of 18.02. Now 5% is by volume. That's not the same as relative humidity. In fact, by volume, this would be rather humid air. But if we do the math again, we can come up with a value of 28.4. And you notice 28.4 is less than 29 or 28.96. What does that mean? That means humid air rises. Thus, now you know why we have clouds up in the sky. And you know what? If we drive those clouds with some sunshine and put it around a planet that's spinning, suddenly we have weather. So not only did you learn about vapor density, today you learned why we have weather.
Okay, well, thanks for watching. Be safe out there, and remember, chemistry's fun.